So we're doing a recap of chi-squared, and chi-squared is also called the chi-squared test for independence. And what's going on will feed our chi-squared function two series. That's what it eats. It eats two series. Okay, that's the input. The output from chi-squared function is that we care about is the p-value. So what's our process for whatever we're doing? Step one, state our null hypothesis. And step zero in here is make sure you have clean data and no nulls and your data types are good, right? But state your null hypothesis. The null for categories, or the chi-squared null hypothesis, is pretty basic. There is no relationship between A and B. You could say no relationship. You could also say, another way of stating the same thing, A and B, whatever those categories are independent of each other. So state your null, run a pd.crosstab. Run a pd.crosstab on df column A and df column B. And then compare. So state your null hypothesis, set your alpha, and then compare your p is less than alpha. And if p is less than alpha, then we reject the null, which means we have evidence supporting the alternative. So what's going on? So I'm going to pull in a couple of libraries here. I'm going to pull in pandas. And then from SciPy import stats. Remember, from SciPy import stats is the new face in this module here. And then, so I have some data to work with. Pull in some data to work with and get a happy little data frame. So we have something to work with. We have a lot of categories in here. We have a gender category, smoker status, day, time. So some of these are binary, some of them have multiple outcomes. Doesn't matter to chi-squared, as long as the two input series, the two columns, or just arrays are as long as they're categorical. Doesn't matter how many categories. So how do we work this? Let's see. The first thing you do is we'll need to make a cross tabulation of the two columns that we're interested in. We need to count the actual. So let's see, what are we interested in? Maybe smoking status and day. So on null hypothesis, so let's see, let's investigate smoking status and day. The null hypothesis is that they are independent. Whether or not a table is full of smokers, what day, Sunday, Monday, whatever, that they're independent. There's no relationship between them. Our steps of computation are two steps. So the observed is we're going to say, hey, SciPy stats, we're going to do chi-squared contingency. You may notice from the autofill, there's a couple of options, chi-squared, chi-square. We are doing chi-squared underscore contingency. And excuse me, I'm lying to you. I'm getting ahead of myself. We need to do the crosstab first. Crosstab of the things we're interested in. I get so excited, I get ahead of myself. So step one, make a crosstab. The two values we care about investigating. We care about all the different variables, but the ones we're investigating are smoker status and time of day. And what observed going to give us back? It's giving us the actual counts. The actual counts of how many people were smoking at the dinner table versus the lunch table versus non-smokers in each. And this, the kind of naive assumption of this is that if we'll get into the assumptions. Yeah, we talked about the assumptions earlier. If smoking status is a certain percentage and day is a certain percentage, then we should be able to multiply those two together if they're completely independent, right? And get a proportion. Reality, there's often not that independent, right? At least that's what we're trying to measure. So now that you have your cross tabulation, you don't need to calculate the expected values. That's underneath the hood. You don't need to calculate the degrees of freedom. That's underneath the hood. You don't need to calculate chi-squared. That's underneath the hood. But what we'll do is stats dot chi-squared contingency. We send it observed. And I got to look this up because this is going to give us like 4 things back and we only care about 1. Okay, so we're getting back from the chi-squared contingency function, chi-squared statistic, which we don't need, the p-value, which we do, the degrees of freedom, which the chi-squared function needed, and then the expected, which in case you needed to output that, you need to do that. So I'm having 4 variable assignments. What's going on when we assign 4 variables to a function, that means that that function is returning 4 things, right? And the only thing that we care about is that p-value. So let's set our alpha, 0.05. Calculate the p-value. Hey, it's really not there. Right. We don't have any evidence to reject the null hypothesis in this case. Right. So it's pretty computationally easy just to crank this out. Where we might use chi-squared in a data science project is not just getting to know our data, which is very valuable for it, but also if our target variable is a category, we could make our target variable one of the columns that goes in. Like if we're trying to predict smoker status or time of day people show up, right? We can feed our target variable into our stats test to understand the relationship between inputs and the target. So it's pretty computationally easy. We are not able to reject the null hypothesis. So there's sufficient evidence that smoking status and time of day are independent. And we can crank this out with other categories, right? We can ask, what about gender and day? Same thing. You do step 1, set your alpha, which we already did, and define your null hypothesis, which with chi-squared, the null hypothesis is always these 2 columns are independent. There's no relationship. Our null is gender and day are independent. Step 2. The crosstab, calculate the observed value, okay? And so we're going to say observed is, and we'll do pd.crosstab of df dot gender and df dot day. So now we have a tally. Again, we can have multiple categories, binaries, everything's cool. And then to produce step 3, run chi-squared contingency to get the p-value. Send in the observed, and all we care about is that p-value. Hey, that's pretty interesting. We reject the null hypothesis pretty soundly here. So there's sufficient evidence to support the claim that there is a relationship between day of the week and what gender the bill payer has here. Yeah, Ryan Miller, go ahead.
Hey, thanks. Quick question. Would you use something like a loop where you would loop through all the categorical tables in a data set or categorical series in a data set and just run this automatically on a bunch of them, almost like that cross plot? I believe it's cross plot. Yeah.
Oh yeah, you totally could. Totally. To do that, you'd make a list of your categorical columns and loop through them all. If you wanted to loop through them all with respect to another target, you could, or you could create every combination of two of those categorical column names, and then loop through that list of combinations for sure. That would be a good and clever thing to do. Yeah. Yes. It's a data frame. It's just a type of data frame. Yeah, that's all it is a data frame. Yeah. Plain old data frame. How do you know it's a data frame? Because you have labeled columns and labeled rows. That's your hint that this is a data frame. If it was not a data frame, you wouldn't have named columns and named rows. Yeah. We can keep going. What about time of day and which day? Right? Null hypothesis is that they're independent. Shader null hypothesis, we calculate the alpha, make your crosstab. So time and day, that's interesting. We have some zeros here. So it seems like Saturday and Sunday, the place is closed for lunch. So I wouldn't be surprised looking at this, that this is probably we'll probably get a low p-value and reject the null, but we'll see. We'll see. We type out chi-squared, comma, p, degrees freedom, comma, expected, and then stats dot chi-squared, contingency unobserved. That's a lot of zeros. Okay. So we reject the heck out of the null hypothesis. There is a relationship, and we saw it right here. The relationship is the place is closed for lunch on the weekend.
Why is the chi-squared statistic unimportant to us? What does it represent? Why do we feel
yeah. Very similar to the t statistic. It's an internal to the rest of the test.
Okay.
If you want to deep dive on what the chi-squared statistic is, we can do math class another time. It's really a transitory computation that you won't need afterwards.
Understanding this correctly, the value is less than alpha. Basically, it says we did have more to investigate what that relationship with.
It's not saying we don't have confounding variables, right? It doesn't tell us anything about the relationship. Sometimes we're lucky enough just to print out the values at C. Oh, they're closed on the weekend. Other times it may be more complicated data that we don't have a domain understanding of, so we'll have to investigate more deeply. Yeah. Cool. So we've learned a couple of things about this data set so far. time and day definitely have a relationship. How do we know? Because the P is low, but how do we actually investigate what's going on? Well, there's no substitute for getting to know your data. We see that they're closed on the weekends for lunch. That means that there's totally a dependency between date and time, right? When we looked at gender and day, they did seem to be have some relationship. Now I don't know. This isn't necessarily like a directional relationship, but our P's nice and low. Okay. And then when we looked at smoking status a day, those seem to be very independent of one another, or time of day rather. Oh. The floor is open for your questions. Keep it simple. Keep it simple. Calculate your observe with a crosstab, then get your p-value.
You don't have to put the alpha in there. It's less than.
Well, yeah. But if I have 47 zeros, I'm not going to bother.
Well, I'm saying, I mean, if we already know, do we have to even do that? Is that even?
I would. Yeah, I would. Yeah, why not? Yeah, keep yourself honest, right? Yeah, hey, Jen.
What I've kind of seen here is like, I mean, this is really close.
Mhm.
Like, what I would say is that the next steps is like. Okay, obviously, it's every day, this day, like, from that point, we want to like a T-test, like, if the interest is like, money related to the time, right? Or like, we continue on with the tests, right? That makes sense.
Yeah, we're gonna, I mean, every one of our data sets is a piñata. And every one of your tests is a new piñata baton, right? To get you the candy. So,
That's great. That's, well, I guess what my question is like, from this point, I would assume that we suddenly start looking at other types of our testing. Going further. Is that correct?
it depends on the data itself. And that, yeah, in this example, total bill and tip are my only continuous variables. So I could run correlation between them. There's probably a correlation between total bill and tip. It's probably a correlation between total bill and table size, but we can confirm that. A t-test would tell us if the total bill, the average total bills by gender are different. Yeah, correlation would be number and number. T-test would be number and binary. And something similar to a t-test, ANOVA would be a number and a category of more than two things. Like that.
I think I was thinking like business perspective, like you just like tell your person, yeah, obviously we're like closed on the weekends, so for lunches, that doesn't mean. Now let's go further and look at what that means for your business. That's just what it's.
Yep. Absolutely. All right, you ready to jump into it? Okay, cool. I'll send out this specific notebook to share with y'all, and the curriculum is also available for you. The biggest thing, folks, don't overcomplicate this. Do the two things. Get your cross tabulation and calculate chi-squared. Okay. You put all the math stuff there so that it will have a little more depth than just run two functions.